think I'm good. I had a one beer just before the meetup because I had to finish the slides.
So, welcome everyone to the March edition of the Clojure Meetup. We have two talks today. One by Juraj about CodeScene, he's going to start. And after that, Vita is going to talk about Unwrapper, if I remember correctly. And for the first time in this nice location, I don't know, Vita, do you want to say a couple of words about the background of this? And I don't know if people haven't figured out how to get a drink.
So, I'm here. I'm also one of the partners at Conway, which is at Sorry, and this is our lab space, which we have since basically last week, and so we can use this here for free. And yeah, you can rent the space if you have any company meetups or whatever. It's also supposed to be a little bit like a co-working space starting in spring. There will be nice outside seating as well if you're interested in that. Other than that, toilets are in the back. There are drinks, there's coffee, there's water, and if you have any questions, just let me know.
And coffee and water is for free?
Coffee and water for free, soft drinks and beers, there's a price list next to the cash registry.
Okay, excellent, thank you. So, Juraj,
Okay.
it's your turn.
So, hi everyone, I'm Juraj Martinka, I live in Brno, and today I will talk about CodeScene and one of the greatest enemies of software developer, and that's technical debt. So, just very brief info about me. I've been a Java programmer for a long time, since 2008, and doing usual stuff like Spring, Hibernate, and some services for financial BI and hospitality industry. I got interested in Clojure around 2013, but really didn't get it back in that time, and retried it in 2015, and it finally became like a more obvious, or I finally saw some benefits in learning the language. So I just started looking for a job, and finally ended up in a company called Empire. It's a small company of 5 people, founded by Adam Thornhill, and the ideas behind CodeScene are really his own ideas and based on his research, and he has written some books on that and stuff like that. So nothing I present here is like from my head or something. I have a blog, curiousprogrammer.net, and try to record some short Clojure tip of the day screencasts from time to time. Okay, so just brief agenda. It's nothing formal, like I mostly show you some demo and try to explain the features and ideas. I will briefly show why I think, or we think, the CodeScene is unique and important, what it really is. The main part will be the demo, mostly analysis of Clojure core code, then very high level description of how CodeScene works, and finally why I think Clojure is a good choice for us, and perhaps what are the places where we don't use Clojure and why. Okay, so the common case in software development is that we spend most of the time doing some modifications, not really creating many new features, but like doing some small modification in existing code bases, and that's where technical debt can quickly kill our productivity, and it's really inevitable thing in larger projects, and we need to learn how to handle it effectively. These are more like basic observations, not laws, but we have these conflicting forces when for the system to remain useful for its users, we have to continuously add new features, but on the other hand, as we add new features, the system gets more complex, and we need to proactively reduce technical debt, and so we can add more features in the future. Otherwise, we might get killed by technical debt lurking in the dark and waiting for his opportunity to do some unexpected stuff. I think that we might get an impression that because we use Clojure and it's such a lovely language that we perhaps don't need to focus so much on improving our code bases, or that it's somehow automatic or something. But I guess it's quite the opposite, because Clojure gives us the tremendous power and quick feedback loop. We can rapidly evolve our code base and add more features much more quickly than, I don't know, with Java or something like that. And I think that's also the case when the technical debt can quickly accumulate. So we have to be aware and be proactive and learn how to identify the parts of our code base that needs improvements the most. The idea behind CodeScene is that not all technical debt is made equal. We really should focus on the parts that are the most critical ones, and when we focus on them, we can get a great return on our investment, because it's quite difficult to refactor our code while still being able to add more features. The thing is that usual static analysis tools, I don't know, find bugs or whatever, check style, Sonar, which combines multiple of them, ignores the time perspective, like the evolution of code base, and we don't have this information in our code itself, but we have a great place where all this data are stored, and this is our version control system. So we can use this version control system to support programmers' intuition and help them to identify the places where they should focus their efforts when refactoring the code. So here comes the CodeScene. It's a web-based tool, web application, written mostly in Clojure, and it combines this usual or common static analysis with behavioral code analysis based on the data that it gets from a Git version control system. It's a language neutral. The basic analysis it provides can be run for basically any language, Java, C#, JavaScript, whatever. We have like two versions. One is cloud. You can find it at CodeScene.io, and there you can register and just analyze your projects, your public GitHub projects for free. And we have also some on-prem installation which customers can install on their servers. Okay, I think the best way how to talk about it is to show you some analysis. I just need to, okay. Can you see it?
Yeah.
It's not that big, but I guess it's okay. Okay, too much. This is the result of analysis of Clojure core, Clojure the language. When you, maybe I will just briefly, I can't see it on my screen. This is just the main page that you will see when you log in CodeScene, and these are a bunch of projects. Okay, so here I have Clojure core, and when I click it, it will open this analysis results. There's basic dashboards that shows you. It's already an interesting, although there are certainly tools that will show you this as well, but it's nice to have it in one place, and you can see where a project started and perhaps how many lines of code are there, like 40,000 lines of Clojure and 40,000 lines of Java, etc. And here it shows some basic statistics. The core term or keyword in our terminology is hotspot, and that's basically the module file or whatever that is complex based on the basically lines of code, and that changes often. So it combines like this static complexity with time aspect. So, and we argue that that's those hotspots are the things that you should focus on, because there's an evidence that most bugs happen in these hotspots. So when we look at the Clojure core, we can see here this is the Java. These are the Java classes, and these are the Clojure namespaces basically. And obviously, in case of Clojure, the biggest file is code.clj, so nothing surprising probably here, but I think it can be used for demonstration. Here we can see some basic data that main author is Ruchiki. And this is basically the high-level information that you get when you run the analysis. You can see a bunch of other files here, and when you identify some hotspot, usually it will be something like more comparable classes or modules in your system, not just one big core.clj. So you would identify such hotspot, and then you can run this X-ray, which runs analysis on a function level, because it's not enough to just know that there's some file with 10,000 lines of code or something. So when you run this X-ray, I already ran it, so it opens instantly, but it's not run in the normal analysis. So you can see the most complex functions. Again, it combines the change frequency and the lines of code metric, so it's like combination of static analysis and time dimension. And then you know that you can focus on this file. You can see some complexity evolution over the course of the time. Here it seems there be some focus refactoring or something, and again increasing complexity.
So complexity is the combination of rate of change and lines of code in your system.
Yeah.
What's the WS, the unit besides complexity? The previous chart
on the graph.
You mean here?
Yeah, the unit beside complexity.
The y-axis.
Yeah, here. Well, I don't know, probably.
Okay.
It's a combined axis. There's two graphs, right? There's a blue line.
Lines of code. Yeah, I'm not sure what this really means, but perhaps. I guess it's not a. Okay.
No problem.
Okay, I can figure it out later. Okay, so then you now have somewhat better intuition on which parts of your code you should focus on, and these are usually things that experts know already, but it's good to have some data to back up your decisions, and it may be useful for newcomers or like to introduce them into the code. There are some more things like internal temporal coupling, and this may be less obvious even to experts. And sometimes there are like interesting correlations, maybe not on function levels, but also there is this temporal coupling thing that happens, the coupling between files. And what that means is temporal coupling means that two files or two functions change together in one commit or in one commit group of commits. So it can tell you that either they are very similar, like copy-paste or something, or you may use that as detection mechanisms for like to inform you that, to warn you that you forget to change some file for, I don't know, whatever. Maybe you typically the implementation and test changes together. And we have Jenkins integration that can run like analysis, what changes are in your Git branch, and can warn you if you forget to change file that typically changes together with other files. So that's one interesting implication. Yeah, so just for demonstration here we see max key, min key, and yeah, you can see that it may be better to just refactor this functionally because they are really similar.
Oh my god.
And that,
really? That looking, or is this their actual code?
yeah, that's the real code. I ran this today, so I guess it should be up to date, Clojure 1.9 something.
It's a very good example.
Yes. Okay.
It's just one character difference, basically, right? Exchange the
Greater and smaller, and that's the idea, and least and greater, yeah.
Just need a higher order function.
Yeah, so you can find this in Clojure too. Okay, so moving forward, we have these refactoring targets, which basically are just prioritized hotspots. The files then changes often are complex, and there is some kind of machine learning algorithm that tries to like prioritize between them, and so you can know that you will probably get most benefits if you focus on core.clj compiler or RT-Java.
Is that identical with the hotspots?
It's like these are the hotspots, but ordered based on some kind of preference that we expect that these are the most useful ones to focus on, to just give you another clue what you should focus on. So yeah, so just again quick look at, for example, compiler, and it seems that I didn't run with analysis before. So it usually takes a while because we have these two types of analysis. Like one is just on file level, like counting lines of code and perhaps indentation or something, just basic complexity measures, and that's why it works for most of the languages. And this X-ray works on function level, and for this analysis we have to implement like parsing grammars. So these are like simply. Sorry?
You also do this on Java. That is the analysis. No, because there is a Java file up there.
Sorry, what?
It works in every language. Wow.
Yeah.
But this X-ray is presumably restricted to a certain set of languages.
Yeah, these are like more restricted, but we already have, I don't know, many languages: Clojure, Java, C#.
Is it tens of languages or
Languages? Tens of languages. And basically our criterion is if a customer wants it bad enough, then we implement it.
Okay.
Again, Adam did most of this work, and he's able to implement it like mostly in several hours or more, for more complex languages at most few days or something.
And so you basically just point it to your version control repository, and it's
Yeah, I can just quickly show you. Here you can create new project, and what I use most often, because it's simplest for me, is specify remotes. Here I paste, for example, GitHub URL and just some local path. There's one more step, just like specify where you want to store your analysis results, and that's basically it. Where's my cursor?
You don't use a codec from Richiki?
No.
Okay.
No.
It's like his demo app for Datomic, like he released it when he released Datomic.
Oh, this is Git repository analyzer.
It imports your Git repository into Datomic, and then you can do various analysis with just core the Datomic.
Yeah, run queries on the Git commits.
Right. That's only for Clojure, I think. So it takes apart namespaces on to a function level.
Yeah.
I think, yeah.
Right. But it has like this adapter thing where you can build adapters for different languages, and I think they also have Java for that.
Okay, so this is just X-ray analysis results for that compiler. And just quickly show you again, that's Java code that seems to be quite complex, so it might be a good candidate for refactoring. Yeah. I mean, Rich is probably smart enough to write such code.
What's the difference between internal and external coupling?
This is like a coupling between the functions inside, and this is I don't have any example here, but it's like between functions inside the class, and external temporal coupling is perhaps between functions from different classes or modules. I don't know if there's anything super interesting here. Perhaps better to move further. And here is the temporal coupling, but on file level. So you can see that, for example, persistent array map and persistent remap often change together. Sometimes you can find something surprising here. I don't know. Perhaps locking transaction on ref. I don't know the implementation details. But yeah, that could be interesting to explore.
So this is also language sensitive?
No, it's not. This is on the file level. The ones that I shown you before. Yeah, those refactoring targets. This is on the like function level, so we have to write grammar for each language here, but again, it's not that complicated, and we usually like don't have full grammar that would parse the complete language, but we have just like simplified version, and the cool thing about that is that we can actually parse the language quicker because we don't need all that information. We just need like basically recognize the function boundaries and stuff like that.
Which languages were hardest to analyze?
I heard that something like Scala was quite challenging and C. Don't know the details, but I can imagine that Scala is quite complicating language, so yeah, that's probably.
Well, Martin Odersky always says that the spec for Scala is only 10,000 lines.
Yeah, that might be the
Less than
reason.
XML.
It's not a bad one.
Can you go back to this temporal coupling thing? There was this graph and I think these checkboxes. They seem to be language specific, exclusion filters. I think that's why we were asking.
Yeah. These are just like common things that people tend to have in their code bases and that you might want to exclude by default.
So if you change
you basically don't want to display that I don't know the class and corresponding unit test, they often change together, so you don't want to pollute your results here.
So you haven't found Python tests in Clojure?
You don't have, but these are just defaults.
Okay.
Do you have, like, you could also have matchers really for other languages if you wanted to? Like, I don't know how easy that would be to plug in.
Yeah, there are some.
Customizable?
I don't really play with that very much, but there are some. Here are some filters, so you can add your own.
Just regular expressions.
Yeah. So these are the default ones, basically.
I see.
So it's very configurable, I would say.
And what's the meaning of that graph that was there at temporal coupling?
You mean here?
Yeah.
Just a visualization that it's not very big, and I'm not sure how to make it. Really doesn't get much better, but just visualization that persistent array map is somewhat coupled to persistent hash map, map entry, and persistent tree map. Like basically another view of data from the table.
Okay. Does the curvature of the lines have any meaning, or is it just to...
I think just to visualize it like clearly or something. Nothing special behind there.
From string to string, the two upper.
You mean this
no,
one?
Graph. You have string, and this connection between them. What does that mean? Is it an internal?
Well, I'm not sure if that's the same file or not. It doesn't show any significant coupling yet. That's probably between the same file. Here are some interesting hotspots, but probably nothing super important, just basic functions. Okay, I would move forward. Probably there are still some things. These are the technical debt section. Shows the basic analysis, and then we have similar concepts but on a higher level. You can basically define that some subset of your code forms a module or architectural component, and then instead of files we analyze dependencies between the modules. So this is quite basic, but here you can see that the biggest hotspot is Clojure Java implementation. Here these are the Java classes, so we treat or visualize it as a single thing, as a single hotspot. So you can drill down into a complex system by identifying the most critical component and then perhaps drill down into that component and identifying individual files there and individual functions which should be improved. And this is something you have to configure somewhere here. This is the new thing, that editor. So you can, here are the components that were defined, and you can just mark them and create new component. Okay, so that's really not that important. We have the section called Conway's Law, where we argue that teams or the code structure should be aligned with organizational structure, and the team or single team should ideally work on one component, not two or more teams working on one subsystem, or how do you call it, bounded context or something in DDD. In Clojure Core, it's not that interesting example. Probably the bigger system from some large corporation would be better, but I don't have one. But you could see that multiple teams are working on a single component. That's exactly not the case here, but yeah, I have some unassigned developers here which are probably not from the Cognitect or are less known, and here's the core team. So there are at least two teams that seems to work on a single component, and there might be some problem, coordination, overhead, bottleneck or something.
And do you have to set up these teams manually, or is it working?
Yeah, you basically need, because there's no way how we could know who belongs
so
where.
you went in and set up, and
again there is
team members.
If you are interested, here's again the Teams tab, and here you can add your teams, and then you can see here are many people contributing to Clojure, and for each one you can just leave unassigned the default one. Or
why is the same person? So there's, what's it, Aaron Bedra?
Aaron Bedra and Stuart said it's probably pair programming thing, I would say. And recently Adam made a change to CodeScene where he supports these things when you specify the pattern, how people state that they are pair programmers in commit message, and we parse it and just and then we just know that there are actually two authors for a single commit.
Is there a standard for that in general, or
I don't think so. There's a standard. You basically need to give CodeScene the proper pattern that you use.
And what about commits that one person authored and another committed, like for rebases and this kind of stuff?
GitHub, you mean? Oh.
Yeah, in Git there is a distinction between the author and the committer, which is for example, if you get a patch via mail and you apply it, then it still shows the original author, but who is the committer? How is this handled in the tool? It's the author probably.
We take the author of the message, not the merge commits. Break your statistics, so that should work.
No, it's not merge commits, but should still work probably if you take the author field, yes.
There's 2 fields in each.
On each commit, yes. Because you can cherry pick and rebase and this stuff where you modify the commits.
And this is when it says in GitHub committed with.
Yes. So it's also a feature on GitHub and GitLab also probably.
Okay, so yeah, there you can see some knowledge loss. This can happen when important developer leaves the company. Here we don't see anything. The loss would be with red color, but you can again mark. That would be fun to mark. Rich.
You could play if when. What happens when Rich Hickey leaves?
Yeah.
Cogitech?
You can mark Rich as ex-developer. But yeah, then you need to. I'm constantly losing cursor. Then you need to rerun the analysis. We can wait for a while. It takes something like 1 minute or a bit more. And yeah, I wanted to mention performance, but maybe I can do it now. I think it's usually quite good. We on like quad-core machine, we were able to analyze whole Linux repository in 45 minutes or something. So the CodeScene can handle a really large code bases too. So that's usually not a problem, and I didn't hear many customers to complain about the performance. There are certainly some possible improvements, but we are quite happy with what we have now. Okay.
Can you show some, or can you tell of some of the most surprising findings? Like you analyzed an open source project and found something which was kind of cool?
Again, Adam is the person that did most of this stuff, but I think I have here.
Quite eloquent.
Yeah, this is the analysis of C# garbage collector.
Oh.
And that's a huge file, like 30,000 lines of code or something. And I wouldn't say that Adam found one mistake when he wrote a parser for this. And I wouldn't say that it's super interesting. It was just like missing brace or something, but that was the real bug in critical part of code, like garbage collector for important programming language. So yeah, I would say that was both difficult and quite interesting to find. And that's file called gc.cpp. I think he found it when he was writing the parser for C++. So here's the description, and that's an article on our blog. Okay, so where I am. Sure, if analysis, yeah. And now I should be able to. Where are we? Go to architecture, Conway as well. Yeah, and you can see there's huge knowledge loss if Rich Hickey leaves. Okay. Okay, I would probably move forward. There are just very quick social analysis, which for some projects and teams can show you interesting data. These are basically the most active developers, and the ownership of various modules. So Rich owns most of the code, and there are, I don't know, Stuart Holloway, some things in tests. So here we can see that Rich doesn't write tests. And yeah, stuff like that is there. Some coordination needs between different developers, and you can find the files where there is high coordination needs. So you might want to optimize your organization structure or structure of your code. So,
but how do you find these numbers, like the nation needs? Because
it's like it detects whether multiple people or teams are changing the same files or modules or some bigger units.
But you need those definitions of teams in order to work.
Sure. Yeah, but this also holds for individuals, you see. So these are basically between individual people. So you don't have definitions of teams strictly for this. We have teams here, and these are coordination needs on team level. So this is similar, just higher level. And here are the authors. This is just basic statistics, for example. It can be interesting for someone. And finally, project management. And I don't think there's anything interesting here for Clojure, but there was something for Reframe at least. This is the recent addition, like might be interesting for some people. This shows you the branches that have been active for a long time, so you might be better off like trying to merge them as soon as possible, and also tries to detect the delivery risk when you merge this feature. The high delivery risk may mean that the code in that branch modifies some hotspots or important parts of the code, or perhaps our author is not skilled enough, meaning that he doesn't have many contributions to the code base and he modifies the crucial parts, and that's why we increase delivery risk there. Okay, so that's just an example. Okay, I guess we spent enough time on this, and so I will probably quickly, where's presentation, wrap up. Okay, so that was the demo, technical depth section, which is basic technical statistics, architectural higher levels, social analysis, that knowledge loss, coordination needs, stuff like that. Project management, we just seen that Reframe, and I skipped this, but it's like basic warning on the main project dashboard, where CodeScene will show you that you perhaps have some rising hotspots, that files that weren't hotspots are hotspots now, and stuff like that, so you can take proactive actions. I will probably go through this very quickly. There are multiple stages. As you already know, we take our data from Gitlog, we parse it into internal data structures, and then run a bunch of analysis on them, on that structure. We store intermediate results and the final results in CSV files, and then the application can just get results from CSV files and present them to the user. As I said, we have two applications, cloud and on-prem installation. They are different, and they both use this common analysis module, which does all the analysis logic. So they just trigger the analysis, and then when it's completed, they parse those CSV files. There's no okay, just quick visualization. It's not that interesting. There's some Jira on the left, but it's really not the same kind of input source as Git. You can connect your Jira instance and to gather some information about issue tracking and to perhaps group your commits based on the single Jira ticket. And there is some, at the right end, there is some risk detection and stuff like that. It's like the basic idea is that the core logic is encapsulated in one model which doesn't even have database or something like that. It tries to be as pure as possible. And true is that it stores the results in CSV files, so there are some side effects, but otherwise it's quite clean.
Excuse me, one question. You mean you parse the Git repository and then you transform it to CSV files and then the CSV files are the basis of the...
No. We parse the Git log and transform it into like in-memory data structure. This is really old, but something like that. You see the section of from Git log, and there's some programmatic representation, and then we run those analyses and detections and stuff like that, and store the results on the disk. So later you can retrieve the results and represent them however.
For the representation of chat or stuff like that.
Yeah.
The CSV files.
Yeah. These are like separate applications which just use this shared library for analysis. I mostly said these things already, so I guess that's not that important. As I said, we use Antler. If I remember correctly, Adam said that he tried to use Instaparse before, but it was too slow or something. So he finally ended up with Antler. We have small number of Java classes for that Antler, but nothing.
Have you tried any of the other declarative parsers that exist in Clojure?
No, I think the idea is that, or maybe I don't understand what exactly are you asking for. If we...
Well, in my experience, as nice as Instaparse is, its major drawback for my use cases has been that it's completely strict, so that it's not a streaming parser. You can't just run a string to it, but you have to realize that the string to be parsed, and then it parses it all in one go, which, I mean, I don't know how if it's too slow, if it would be too slow otherwise, but that's definitely a
memory consumption, memory footprint is high. Yeah, I think he mentioned that was an issue as well.
Yeah, and if you were to build a parser on just pure functions, like you do in Haskell, I don't want to say the word, but you can do the same in Clojure, where you just define parser functions in a streaming way. And I think there exists 2 or 3 frameworks for that, and how that goes up. But
yeah, I think we didn't try that, but currently the process is like quite straightforward, and you spend the time mostly on defining the grammar with this Bacchus now form or something like that, and then you are pretty good to go.
the Antler parser you have created, is that streaming? I haven't tried that out yet.
Sorry?
Is that the streaming parser that you get out of Antler?
Yeah.
Oh, that's good. An incremental parser.
Yeah, so yeah, I guess it's much faster than it was before, so, and that's like nice plugin for IntelliJ IDEA and stuff like that. Okay, that's already what I said. Performance, that's like just an observation that we actually don't run many analyses in parallel because our main bottleneck is memory, so we rather run them step by step. And just a very brief overview of some libraries if anybody is interested. I heard they mentioned that Encounter was quite buggy, so they re-implemented some statistical functions by themselves. We don't use Clojure script just for one separate application, and we mostly use server-side rendering and Selmer for rendering the HTML templates. The on-prem application uses H2 database. There's simple scheduler based on core async, very primitive. And we have some basic third-party integrations with LDAP as like so you can get notification when analysis is complete. I experimented with a few UI tests in that Etaoin, or how is it called? It was quite nice. Okay, I should probably wrap up this soon. You already know all this stuff, and I really seen that for our founder it was incredible how quickly he can add new features into quite complex code. So that's definitely a good testament for Clojure capabilities, and it also matches our use case. We do a lot of data transformations. We have Swedish king in our office, and he actually didn't say this, but all of the people were quite surprised that there are just 4 or 5 people working on this, and even more surprising is that basically one man wrote most of the interesting parts of the code.
So you have analyzed your own code.
Sorry?
So you have analyzed your own code and found out that you have high.
One main guy.
I run some analysis on our code when I change something, and then can be interesting. And yeah, there is even the guy that left the company. He was focused on the UI, and we can see some knowledge loss there because he did most of the some JavaScript coding and CSS. So there are clearly some parts, but it's not that big problem. And the one other thing I would say that the CodeScene is the most interesting for big companies. On personal projects, probably not that much, but medium to large projects, it's definitely helpful. We have some other things. Perhaps we will have some IDE plugin written, maybe in Kotlin or something. We just try to use what's the best for us, so we don't try to force everything to be in Clojure, but most of the code is in Clojure. Okay, so we're coming close to the end. My point was to make that the technical debt is a real problem in probably every programming language, and encourage you to think about it and perhaps try some new techniques and tools how you can eliminate it and have better and maintainable code base. The idea certainly isn't that it should replace human or people's experience, but that it should support their decisions. Some resources, I can send you slides if you want. Adam has quite good tools that can explain this stuff much better than I can. And you can try it for free if you want and have some open GitHub projects. Okay, that's it.
Thank you.
Any more questions?
Yeah, I've just ran the tool on my favorite project of mine, and the main thing I'm noticing is since it's written in a language that the tool apparently doesn't know, it just ignores all those files.
Yeah.
Can I contribute a language recognizer for that in any way, or is all of it just proprietary?
Yeah, that's unfortunately not that easy.
What's the language? Haskell?
Yeah, that might be a problem. Where is my screen? But if you are really interested in this stuff, you can try to. But actually, I'm not that sure what's here. But this is like a very. This is like a very restricted version of our tool, and this is what Adam has written. He still maintains this, and it's like a less capable version of our tool. He describes that in his books too, and perhaps you could.
So you're using that library, or?
No, we don't use that. We have our own library, but this was like evolution. He wrote this thing first, but then.
So I should probably get in touch with you directly if I wanted to.
But at least it's in open source, but I'm not sure if and where are the grammars.
This is already the iteration that you landed on with the Antler parsers and this kind of stuff. Or wasn't this for the code files at all?
Unfortunately, it seems that here are the parsers are not here. That this is basically just for. Yeah, you can see there are some other version control system, but this is basically just for getting data. Yeah, it looks like that's not a support for this X-ray analysis. It's like on file level. So yeah, unfortunately, that's probably not an easy way how to contribute. I can ask if he could.
I mean, the syntax is pretty close to C-style early languages, so it might not be that hard.
Yeah. Yeah. Okay.
One more question, because you analyzed the Linux kernel. Did you do any analysis on, like, Linus Torvalds is pretty famous for using swear words?
Yeah.
Number of swear words per 1,000 line of code?
No, I don't think so. I don't think so.
Okay. It would be fun.
So you said that the ingest pipeline, or whatever you call it, the analysis pipeline, is essentially single-threaded because you can.
Yeah, there are multiple threads at the end. I think like running some trends analysis, which is run in multiple threads. But yeah, that's as far as I know, the bottleneck really is the memory, so we don't get any benefits from trying to run those analysis steps in parallel, and actually it can cause more problems.
So how do you parallelize if on your SaaS offering users are starting multiple analysis in parallel? Is it the application running multiple times in different containers? Or how?
Yeah. The cloud version is based on AWS batch, and there are basically Docker containers which are started for each analysis. That's quite different from the on-prem installation.
When you say memory, is a bottleneck? How much memory do you recommend typically?
I don't know. We have like 16 gigabytes, and that's usually okay. But you can configure the project and restrict the amount of data. Like you can say that you don't want to analyze data older than 3 months or something. So you can make it configurable, perhaps make your analysis quicker.
Okay, but if you, let's say, you have only 16 gigabytes and you want to analyze a lot of stuff, can you just let it run and wait overnight, or is it going to crash because the memory is not
hard to say, but yeah, it shouldn't crash, but then you can end up with lots of garbage collection or something for really big projects, so it can actually slows down significantly the analysis.
Yeah, but they should say, okay, I don't care, I leave it running overnight.
Yeah, it should still work. For example, I have a slower computer. It's probably not just because of memory, but it also depends on the number of cores and because of that trend analysis which is run in parallel, and that Linux analysis took way longer for me, but it eventually finished without problems.
But it dies after 4 hours. It runs out of memory and it dies. And
No, I haven't seen that. It worked quite well.
All right. Thank you very much. It was very
Okay.
interesting. We take a short break,
Yep.
and then it's time for the test talk.
Okay, it took.